Hello everyone. I'm Pascal Salman from TS Serema from Toulouse, and today I will present for you our work about evaluation of road users trajectory from aerial view data. Firstly, I will start by presenting ETS team, and then I will go to present our work and our methodology for trajectory analysis based IRL. Firstly, ETS team is a team from a French agency, public agency. We work on developing our expertise on risks and on the mobility of the future. And the ETS team is a research team localized into two sites, one on Toulouse and the other one in Clermont-Ferrand. The team of Clermont-Ferrand are working especially in simulating weather conditions, always about mobility and transport system, intelligence systems. And in Toulouse, we are working more about road users and interaction between users. And all this work is developed inside two thematic axes. The first is towards safer, efficient infrastructures, and the second toward automated driving. And we develop our expertise about artificial intelligence, especially deep learning techniques. We are also interested about digital twins. We also interested about data fusion by using sensors like cameras, GPS, and LiDAR. And we use all this technique we apply it about in the domain of road user, the safety of vulnerable road users. Firstly, when we talk about road traffic systems, we talk about the study of of the behavior of all of different type of users. Especially, we talk about vehicles, pedestrians, cyclists, and also recently we are also talking about the interaction between all road users with the digital infrastructures and with automated vehicles. And the first thing to do about this is when we need to study this type of interactions is to extract trajectory and analyze these trajectories. And this is the aim of this work. Our first talk about this subject is to use road side view to extract everything using, of course, intelligent deep learning, YOLO, or any type of deep learning detection models to detect users. Here we have a problem. For example, automated vehicles is not included in a lot in public data set. We are included it with our with this type of models, and then we detect every different users. We try to ameliorate the models, and we finally we have we extract trajectory in the images. And the problem, if we still in the images, is not sufficient because we have the perspective of the image. We lose the velocity, everything inside the. We have only the trajectories, but we lose a lot of things. This is why we try to calibrate cameras, and we combine the calibrated cameras with our detection to transfer our trajectory into a 2D map. And like this, we have all the display timestamp trajectories inside the velocity, the acceleration is in metric units. However, still, if we pose the question, with this type of data, is it sufficient to analyze scenarios and trajectories and analyze the safety of users? And we have a lot of problem here. Well, the first problem we have, because of a roadside view, we have a lot of problem of occlusion. There are a lot of users with a big probability to be, we can't see it because another user is not supervised by the camera. Because the view is not the best manner to do it. Also, we can see clearly what happens around the users because the view is so close to users. This is why we can see some behavior about the pedestrian, but we can't understand why he takes this decision sometimes because we have a lot of information. This is why we decide to go to area view with a large view like this. We can see everything about when we need to study the behavior of road users. We have less problem of occlusion. We have with one sensor, with one camera, we can see everything in the zone. We can extract a long distance trajectories. We have a better tracking of users. This is why we start finding data, public data, especially about this using IRL view. And we find the data called end dataset in Germany. They propose a dataset with video recorded at with 4 crossroads and 4 roundabouts. And in this dataset, they give the data and they give also all the analysis that we are doing in our roadside view is included in this dataset, and then we have the data with the trajectories. However, we can't have access to videos, images, and then we can't have we can do our own deep learning model. But it is a good start for us to go for the second part of our objective and study and analyze the trajectories. In this data set, as I see, we can see they use an object detection and tracking based using drone to detect and track users, and then we extract trajectories, and we have a classification of all type of users, especially pedestrian, bicycle, everything. However, some users like autonomous vehicles, it doesn't exist in this type, yes, but it's good to start here. And then based on this data set, we propose two methodologies to study the interaction between users. The first method is to identify and classify interactions between each user, every user, and with the other users. And the second methodology, we propose to predict sum of collision risk between users to evaluate the dangerosity. And the two methods is we have the same classification to identify the final situation about safety. So the first method that we propose is based on an object reference. We start with an object reference called A, for example, and based on his velocity and that's changing in direction, we can propose an area like this triangle, that and inside this triangle we can identify all possible displacements that can do the object A, we can tell. and we predict the displacement of the possible position of A in 2 seconds. To take into account the road safety regulation or something like this. We can change this parameter, but we propose 2 seconds, especially because this model is something linear. We can't. It's difficult to predict the displacement more than this. However, this model, the specialty of this model, more the velocity is big, more we can see the angle of the triangle will be small, and more the user or the object A decide to turn in a road side in a road crossing road, for example, more the angle of the triangle will be large. Something like it is a dynamic triangle and instantly evolve. And then we propose to we try to study the position or all the other objects a bit compared with the object A, and if it was in the first circle, it will be a dangerous interaction. It will be in the second circle. It will be uncomfortable interaction, we call it. And if it is outside, there are no interaction with the object A. And then we propose a second method to analyze the risk of this kind of situations. And we are always based on the displacement of the reference object, for example, A in our case. And based on this object, we try to base it on a Monte Carlo plan to predict all possible position of this object in the future, and we try to compare if we can have an overlap with a static object, for example. More they have a cohesion, a possible cohesion with a static object, more the cohesion rate it will be high. Well, this is the two methods that we are proposing, and I go to visualize some of these results that we arrive to, and to resume all this work. First, we start with, for example, a 2D map from in dataset like crossword. We try using drone. We try to register the images in this area, and we apply artificial intelligence detection to detect all objects and track it. And then we identify it, we would try to identify all trajectories by type of user. And the second step, once we have all the trajectories, we try to analyze it. And in this data set, we have 30,000 trajectories for crosswords. It represents this 10 hours of recording. It represents car, bus, pedestrian, and cyclists in particular. We can visualize every type of these users all in the same time, and we can see the displacement of pedestrian, the displacement of vehicle and everything, and we can have a general analysis of what happened in this place. And we also do some filtering procedure to remove all trajectories not complete in tracking system. The tracking system, we always and like this we can remove some 1,000 trajectories, but it represents 7% of that, but it's always okay. Voila. here we can present with this tool. We can visualize everything and the number of vehicles and user each in the zone. And here I present the application of our methodology to with the triangle modelization, and you can see here on the object move, we will see a pedestrian we want to cross. It's okay with the 99, but the 193 will turn. We will see clearly in the 95 will enter in the zone in the triangle or semicircle of the 93, and here we have a dangerous situation, something like this. And we apply this method of all the trajectories we have. And finally, we can detect 5% of all the trajectories of the thousands of trajectories we have treated are in dangerous situation. It is not an accident, but it's something it's not okay. Pedestrians decide to cross the road and don't matter what about the vehicles around, something like this. And we have 2% is the uncomfortable interaction, but it's okay, you can see. And finally, in this paper, we have presented in particular two methods to analyze the interaction between users. And this kind of analysis is very important for autonomous vehicles because autonomous vehicles need to take good decisions. They have no choice because there are no driver in the vehicle to take the safety decision. And in perspective, we are interested to generate our own data using a drone, and we have the same as algorithm. We have our own algorithm. We can apply it to generate our data and to improve this the work in this domain. Thank you very much.